You ever look at a math problem that seems impossibly long or just plain weird and think, there has to be a trick? Well, you're absolutely right. A lot of these aren't about brute force calculation at all. Nope, they're about being a detective, finding a hidden pattern and cracking a secret code. So today, we're going to become code breakers. So here's our game plan for today. We're going to start by kind of rewiring our brains to look for hidden codes in numbers. Then we'll get into some amazing shortcuts for those giant, intimidating sums. After that, we'll learn how to predict what number comes next in a sequence. And finally, we'll tackle those tricky puzzles where symbols don't mean what you think they mean. By the end, you'll have a full-on code breakers toolkit. All right, first things first, this is all about a shift in perspective. The goal here isn't to do more math, it's to do smarter math. We're on the hunt for the elegant, simple solution. So think of every problem we look at as a puzzle, with a really cool answer just waiting for us to find it. Okay, let's kick things off with a classic type of puzzle, the giant sum. You know the kind, problems that look like they'd take you all afternoon to solve by hand. But once you find that hidden pattern, that secret formula, they take just a couple of seconds. Here we go, our first challenge, adding up every single number from 1 to 100. I mean, without a calculator, that just seems like a huge, tedious job, right? But believe it or not, there's a secret key to this, hidden in plain sight. And here it is. This is the master key. This simple little formula, n times n plus 1, all divided by 2, that's our shortcut. And the reason it works is actually pretty brilliant. See, if you pair the first and last numbers, 1 and 100, they add up to 101. Then you take the second and second to last, 2 and 99, they also add up to 101. You can make 50 of those pairs, and 50 times 101 is 50/50. This formula is just a slick way of doing exactly that. So let's see how to use this code. Our n is obviously 100 because that's the last number in our series. We just plug it into the formula. 100 times 101, that's 10,100. Then we just divide that by 2 and we get our answer. And there you have it. This is the power of finding the pattern. What looked like 99 separate addition problems just became one simple calculation. The answer is 50/50. Beautiful, right? Okay. Let's try another one. This time, we're only adding the even numbers, from 2 all the way up to 100. Now that's 50 numbers in total. So is there a different kind of code for this sequence? You bet there is. For any evenly spaced series of numbers like this, what a mathematician would call an arithmetic progression, you never have to add everything up. There is a much more clever, more direct way to get the answer. So here's the trick. You just take the very first number, which is 2, and the very last number, 100, and find their average. That gives us 51. Now, since we know there are 50 numbers in our list, we just multiply 51 by 50 and get 2550. That's it. No boring addition required. And the pattern for odd numbers might be the most elegant one of all. If you want to add up, say, the first 10 odd numbers, you don't even need to know what they are. You just take 10 and you square it. The answer is 100. It's as simple as that. So cool. All right, so these summation shortcuts are pretty powerful, but not all codes are about adding things up. Let's move on to a totally new kind of puzzle. This time, the goal isn't to find a sum, but to predict what number is coming next. This is all about pure pattern detection. Okay, take a look at this sequence. Right away, you can see the rule isn't obvious. It's not like we're just adding the same number over and over, and it's not simple multiplication. So what's the hidden logic that's connecting these numbers? The trick here, and it's a great one to remember, is to look one level deeper. The secret isn't in the numbers themselves, but in the relationship between them. So let's take a look at the differences. And there it is. That's our hidden code. The jump from 1 to 3 is +2, from 3 to 7, that's +4, from 7 to 13 is +6. You see the pattern now, right? The amount we're adding is going up by 2 each and every time. We found the rule. So, following that pattern, the last jump we saw was +12. That means the next one has to be +14. We just add 14 to our last number, 43, and that gives us the next number in the sequence, 57. The code is cracked. All right, time for our final challenge. And this is where we really, truly become detectives. What do you do when a familiar symbol, like a multiplication sign, is being used to mean something totally new? This is going to take logic,
observation, and being willing to just throw out all your assumptions.
So look at this puzzle. Clearly that little asterisk does not mean regular multiplication. Our job is to use the examples as clues to figure out what the secret rule actually is. We can't assume anything. We have to figure it out from the evidence right in front of us. This table breaks it all down for us. For 2 star 3 to equal 12, the rule must be something like 2 times 3, which is 6, and then maybe you multiply by the first number again. Let's see. 6 times 2 is 12. Okay, let's test that theory on the next clue. For 3 star 5, it would be 3 times 5, which is 15, times the first number, 3, again, and 15 times 3 is 45. It works! The rule is A times B times A again. So now that we've found the hidden rule, we can finally solve the original problem. Applying our new code to 3 star 4, we multiply 3 by 4 to get 12, then we multiply that by the first number 3 again, and our answer is 36. So what have we really learned today? I mean, we've seen 3 totally different kinds of puzzles, but they all share that same core idea. You gotta look beneath the surface. Let's wrap up with the tools you now have to solve basically any pattern-based problem. Here it is. This is your new mental toolkit. When you see a long sum, look for a formula. For a weird sequence of numbers, check the gaps between them. If you see strange symbols, question everything and use the clues. And most importantly, always remember the goal. Don't just calculate, investigate. Be the detective. You know, this quote just perfectly captures our whole journey today. We took problems that on the surface looked incredibly complicated, maybe even a little tedious. But by looking for that underlying structure, we found simple, powerful, and honestly kind of beautiful ways to solve them. And that, right there, is the ultimate takeaway. This way of thinking, it's not just for math quizzes. Patterns and hidden rules are literally everywhere, in music, in nature, in traffic, even in a conversation. The only question is, now that you're a code breaker, what codes are you going to spot?